once again, I want to thank everybody for coming. Our next speaker is Miguel Hernan from Harvard Chan School of Public Health. Thank you.
Thank you. So, the last thing you can do on your case from this thing. So I have to go fast. And so they're asking to do it all together. And there was a lot of stuff going on over the last couple of days. It's very hard to put these things together. When they call me and say, what, really? You know, some people have to talk about all the things that all the people were talking about in the last 2 days. You are not attending all of the sessions, of course, but there were sessions on estimating treatment effects, observational data, participant score, ID estimation, IP weighting, D formula, WMAP estimators, mediation analysis, and machine learning. So, a lot. And I'm going to try to give you a quick overview, like a roadmap of where all these pieces fit into the puzzle of our inference. And then hopefully we'll have time for questions to people on the last question. Okay? So let's start with estimating treatment effects. So we are doing comparative effectiveness research here. And comparative effectiveness research was defined by the Institute of Medicine in 2009. We talk about comparative effectiveness as differently comparative safety research, of course, and many of us will take twins on that. We focus on patient-centered outcomes. We are doing comparative effectiveness research with patient-centered outcomes. So the goal of comparative effectiveness research is to help decision makers decide. And by decision makers, I mean patients and doctors, I mean healthcare managers, etc. So as the annual input, we want to assist decision makers to make informed decisions that will improve the health of the individual and of the population. So if you put all these things together, we are trying to generate evidence to compare the benefits and harms of different treatments to make informed decisions that will improve health. So here what we're trying to do is to estimate the health effects of treatment. And by treatment, I mean any health-related action. So that was the easy part. We are all trying to estimate treatment effects here. Let's talk about observational data. So we are trying to estimate treatment effects, and that means that we are trying to answer questions of the type: is better treatment A or treatment B now or later? When we switch to treatment C, etc. All these questions can be visible. Now we answer with a randomized trial. In principle, there is a hypothetical randomized trial that will answer any comparative effectiveness research question that we have. The problem, of course, is that we rarely can actually conduct that randomized trial. We don't have that right now. Because it may be very expensive, it may be practical, it may be so long that by the time that we learn the results from the trial, we are not useful anymore, etc. So for all those reasons, what we do is we analyze observational. There are many different types of observational data. Some of these data sets are created for research, and some of them are not. When we are working with electronic health records data and whatnot, generated for research, and we are trying to make it for research. So this is a key point. We are analyzing the observational data because we cannot come back to randomized trials and have our version of this. So observational analysis are not our preferred choice. No, it's not that we love the observational data so much that we make an inference based on observational data. It's the only that we can, because we will have the but for any analysis that you are doing with observational data, any causal analysis that you are conducting, I'm sure that you can come up with a hypothetical trial that will answer that question better. And that is what we refer to as the target trial. So the target trial is the hypothetical randomized experiment that will answer your contra question if only we do survive. And this idea that causal inference from observational data is really an attempt to emulate a target trial. It's an idea that is present in sometimes in an implicit way only in the work of people like William Cochran from the 1960s or Don Rubin or Einstein, David in England or General. So these are people who have been thinking about causal inference and essentially what they're saying is that we're trying to emulate randomized trials using the observational data. And that is why we use the observational data. So the two steps of causal inference. First, we ask the question. And how do we ask the question? By describing the protocol of a target trial. And second, we answer it. And how do we answer the question? Well, if we are lucky, we can conduct our target trial. If we are not lucky, we will use observational data to emulate the target trial. And that's where observational data comes into the picture. So the protocol of the target trial has different components, like for any normalized trial. We have to define what the eligibility criteria, what are the strategies that we're going to employ, the two treatment strategies, or 3 or 4 or more, how the randomized assignment is done, the and follow-up, the outcomes, the cost account, the analysis. That's what any protocol of the trial has. If we can define these components for our hypothetical target trial, then we know which questions we are asking. We know which questions we are asking. If we can define these components for our hypothetical target trial, we know which questions we are asking. And that's the first step. We need to know their question. And then, once our target trial is defined, we use the observational data to try to emulate each of those components. So, here we have seen some examples of target trials that have been emulated using observational data. If you were with John Seeger, you have to talk about how to emulate a trial of studying initiation and acute-MI without a couple of trials of HIV infection in children. Sonia was talking about immunoscopy screening and antidepressants in pregnancy, Jessica about speech consumption, and studying for the initiation of antiretroviral therapy. Lauren was talking also about initiation of antiretroviral therapy and studies to monitor HIV hospitalization and mortality. In all these cases, you are learning how to mimic the target trial that corresponds to the post-operational image. Okay, so that's the part about observational data. Let's talk about the methods that came, for example, the propensity score method here. Again, there are two steps for causal inference. In the first step, we describe the protocol of the trial. We have this is our question, and the causal question can be mapped into the protocol of the hypothetical trial. And the second is we either conduct the trial or use observational data to use the trial and use a public causal inference method to estimate the effect of inference. So let's talk about one of the components of the target trial that we have to use, which is the randomized assignment. This is a problem, right? Because in our hypothetical target trial, treatment is randomly assigned. But in our observational data, it's not randomly assigned. So some people who are getting treatment may not be comparable with people who are not getting treatment, or people getting one treatment are not comparable with people getting the other treatment. This is the problem of confounding. This is the problem that if you don't understand epidemiology, who does it confounding, if you don't understand economics, you say selection. But it's the same problem. You have groups that are not comparable. So, if we want to emulate the randomization, we have to measure and adjust for the confounding factors. And if we don't have enough information on the components, we will not be able to meet the target. And we will have confounding factors. So, The methods that we use to adjust for the compounding factors are things like mapping, classification, outcome regression, and when we have propensity to force, methods like the formula, methods like attenuating, etc. So, methods to adjust for compounding are methods to emulate the randomization of the parameter. If we have enough information, we have information on the compound, and then we are using the right method, or a method that is right, then we will be able to emulate the randomized assignment of the parameter. That's all compounding adjustment is. We're trying to mimic the randomization itself. If we don't have enough information, we use that. Okay. You also, some of you also heard about methods based on ID estimation, instrument variable estimation. Okay, so this also has to do with adjustment for compounding. And I just said that if you don't have enough information on the compound, then there will be compounding and we will not be able to emulate the target now. But this is not quite true, because there are some methods for which we will need to have information on the compound. Okay, so there are two approaches to try to emulate the randomized assignment of parameters. One is to measure and adjust for all the compounds, all the methods that we have discussed. The second approach is to use sources of randomness that exist in the data to adjust the compound without ever measuring the compound. Without we even know what the compounds are, what the compounds are. These are methods like instrument variable estimation. And these are methods that Thomas Clarkson was talking about. These methods are a long history in the social sciences, less in the biological sciences, but they are being used more. And these are methods that work very well in some cases and very good in many others. These are methods that they don't require to measure the compounds, but they require assumptions that in many cases are very strong and very unlikely to hold. Well, in other cases, they are more likely to hold. And Sonia Franklin was talking about this in two other sessions. She has published a lot on this topic, and you can go over to her papers, and learn more about this. Okay. Then, some of you have been in sessions with many other different types of methods, like iterating and the formula, and that we were estimating. Okay. To talk about why you were learning about these methods, we need to go back to the protocol of the current trial and think about the treatment expressions that we are going to compare. There are two different types of treatment expressions that you have in your current trial. Some of them are based on intervention. There are things that happen at them. So you will assign people to have either vaccination or not, or having surgery or not, or screening for colonoscopy or not. That's a point intervention. It happens at daytime, nothing else is done after that. Or you can think of a sustained strategy over time, in which you are assigning people not just to have aspirin at daytime one pill, you are assigning them to have aspirin throughout the next 5 years as a sustained strategy. You think how most of the questions that we ask are about sustained strategy, because that was about medical treatment, lifestyle, or environmental exposure. Those kinds of foreign exposure happens once, and then the person is not exposed anymore. Those are things that are sustained over time. And these sustained strategies can be divided into the cytokine dynamics. Starting in the objective of phase 1, and 50 years of vaccine propaganda no matter what. And the strategy is when you assign people to the treatment that you will change the treatment and based on how the person is responding, how the person is changing over time. So you say, I assign you to 150 milligrams of daily aspirin for the next year, unless you have an instruction. In that case, that is stuff. Okay. Most medical strategies are of this type. You will assign the patient to this treatment, no other. Okay, so why I'm talking about treatment strategy? Because the choice of the method to adjust compounding depends on the treatment strategy in your target trial. If your treatment strategy in your target trial is a point strategy, then any method to adjust compounding works. If that's not, you can use propensity score, you can use maximum, you can use any method works if you have information on the compound. Or you can use the method of insulin diversion if you have insulin aware conditions. But if you are comparing sustained strategy in your target trial, if you are not interested in the target strategy sustained or time versus another strategy sustained over time, then most methods to adjust the compounding will not work. You can use propensity score in general, you can use insulin variables in general. You have to use methods that are not GMAT that have been developed by Miguel Hernan and others in 1980. So depending on the type of strategies in your target trial, you will go with any method. Essentially, some people are obsessed with some method and they will only use propensity score maximum fine, while people will only put the compounders in the more adjustment fine. They are all going to work. If you have enough data sets and you have enough data on the compounders. But if you are interested in sustaining a strategy, then you have to be very careful of the methods that you use. It's not all methods are going to work. Okay, and why does that happen? That happens because when you want to use the method of sustained treatment strategy using observational data, in the observational data, the treatment is going to be time variable. It's going to be a treatment that changes, and we want to know what happens if it changes in the way that we want it to change. So when the treatment is time variable in the observational data, the compounders are also time variable. So you have time variable treatment and time variable compounders. And the problem is that once you have time variable treatment and compounders, it's possible that there's a feedback loop between the treatment and the compounders. And if the treatment affects the compounder in the future, the compounder affects the treatment in the future. So, and if you're an example, you're trying to estimate the effect of anti-retroviral therapy on whatever, some outcome on that. CIMPOD count won't be a compounder for anti-retroviral therapy at time 1, because you have an CIMPOD count that would like to take therapy. But CIMPOD count at time 1 is affected by what you have been on anti-retroviral therapy at time 0. You can do this every month or every time unit that you have in that. You see that this feedback between the treatment and the compounder over time. That treatment compounder feedback cannot be handled by standard statistical methods to adjust all the compounders. That is a GMAT. That's why when we are trying to estimate the effect of treatment strategies in time treatment, we need to use GMAT. And the three main groups of GMAT are the G formula, G estimation of is performance, which was not represented in the symposium because it was used much, and isolating of marginal effect. And then there are some better ways of using these methods in some settings using very robust estimators. So some of the examples of the use of new methods that you saw here in the symposium to estimate the effect of sustained treatment studies where the sample times together, Jessica and Maria. So that's why we were talking about all these methods, because not all methods can be used all the time. Then there are also a couple of symposiums on mediation analysis we are done. And mediation analysis is really just a particular use of here, the goal is not to estimate the total effect of a treatment, but to estimate the effect of a treatment that is mediated through some factor, or that is not mediated through a factor. So here is like we are trying to do a target trial. I have two treatments. One is the treatment of interest, and the other one is the mediator. So everything that I said so far of having to adjust the compounding, having to use the right method, that all applies to mediation analysis. With the difference, and now we need to adjust for compounding for both the treatment of interest and the mediator. And we have to use methods like adjustable quantum box. And if it is a sustained treatment, we will have to use GMAT. If it's not a sustained treatment, we will have to use GMAT. But besides some of the technical issues that happen when we are trying to do mediation analysis, from a conceptual point of view, is the same as the rest of the population, and now we have two treatments rather than. And of course, that means that we have to make some assumptions, because we need information on all the factors for both treatments, not just for one of them. Okay, and the last topic that was discussed in this discussion, Sarah Ross was talking about machine learning. And machine learning is technically, it's not a something that machine learning was not developed for science, it was developed to occupy things, to find the best, to find a pattern of variables, etc. And that's what Sarah's symposium was yesterday. Today, she talked about applications of machine learning for causal inference, and this is a very hot area of research that many of us are very interested in. We still don't know how to use this information in the future, but we find it. Okay, so I tried to put it all together quickly and try to save some time for questions if people have questions. Just before I finish, I just want to make sure that we will keep this in mind. We want to do analysis because we can not do any same person in this room, I'm sure I was saying, we would prefer a randomized experience of observation and give given the option all things in the room. But we don't have that option. And that's why we do observational analysis. There is no alternative. So we have a responsibility to use this observational data, these large databases that we work with, we will use them for. So thank you, and I'm happy to take questions.
So I have one clarification and then one question. They were very brief. My clarification was when you said that in a point intervention scenario, all methods work. I initially was questioning that just in thinking in terms of some scenarios where maybe you would have to match because of lack of overlap of, say, propensity score. So I assume really what that means, which is implicit and is that they all work under the assumption. So there might be a case where you don't have positivity across the range, so matching might work, but I think that you wouldn't. So I just wanted to get your input. I was thinking of that, right? My question though was, how do methods like those like Earl structural puzzle modeling fit in with this discussion? I always get confused. Right?
Okay, so first of all, this is where you are right, and I think that's not all methods work, I mean, it's running well. So you have normal creativity, you can do those people. Well, the methods, matching strategy, I can do. As for the methods that you mentioned, so there are a theory one that it doesn't give us a way to analyze data from the level. It's a way of explaining how we can follow our instructions.
Yeah, I have a question regarding the talk about protein intervention versus sustained intervention. I feel like, based on my own experience working with observational data, I feel like in observational data, nothing is point. let me give you an example. So we were doing a study looking at the effect of AVF for vascular access procedure for dialysis patients. So AVF insertion versus AVP. So it's a baseline, it's like a point intervention because it's surgery and usually at one point in time. But the thing is that when you look at actual data, that's not a case. I mean, AVF insertion is not mature, failed, people do another surgery. And in the first 3 months, you will see that the if you do a different surgery, like you said, or extensive surgery, and do again, it's like pretty high, like 20% of the population doing that. So in that case, I mean, still all methods work. So for that kind of situation, are you still going to define the treatment strategies at home?
That's kind of important. It depends on what you have. If you say, look, people have never had this type of intervention, this type of procedure. People have never had. I am considering this type of trial in which I have made like a procedure at A or at B. Now that's a false intervention. But if you say, well, I'm considering a trial because in the language of people try to procedure A now, and if it fails, we will do B, versus do not do that and wait for 6 months and then go to B, or do A and if it fails, go to C. Not the same intervention. So with the same data, you can compare different things. That it all starts with the question. So whether you are interested in a home intervention or system intervention, it's not a function of the data, it's a function of the target file. You define your target file as you go to the hospital, then you can use it.
Okay, so in this case, in the example that I just described, we need to redefine our target file, correct?
Right. Because you want to look, I want to analyze target file with people who know this procedure outcomes of A1. That's what I'm going to do. And I look at the data and say, oh, no one like that. Because they always start with A. And if it fails, they go out to B or C. That means that I have an individual person and I know well, but I have no way of emulating using the data because there is no one following the strategy of the data. This is true for almost every component of the development trial, well. With the there is an iterative process between the trial and first, which we would like to emulate. And then we will look at the data, we see that something kind of possible. We can compare settlements in the criteria, we will have data from those, we can compare settlements within the studies, we will have data on those organizations. The iterative process is to modify our target trial so that we can take some criteria that we can use from the data. And if we modify so much that at the point we are not interested in that trial, then we don't have the content.
A lot of these methods have one very common assumption, especially to the SW phenomena and stuff, that you assume that there are no unmeasured components, because in the world. But when you look at real data, you don't know whether like most of the data will have some unmeasured components. So how do you generalize these methods to incorporate?
Well, all these methods are based on the assumption that we have enough information on the data, on the factors that affect both treatment and that we have no components. If we have important components that are not in the data, these methods will give us garbage. Nothing we can offer in interpretation. So it is very important for us as researchers to use our experiments, our subject methodology, to look based on what we know, based on my colleagues know, based on what the scientific community knows. I don't think there are any components that I am adapting. If you can make that better, let me know so I can because of this, we need to be very careful. And this doesn't mean that we have all the components. That's the reason. We work a lot with here Medicare. This is a linkage of the here cancer registry with Medicare. We love to use those data to compare different cancer treatments. So when patients with lung cancer, we like to compare treatment versus treatment. And we have information, very detailed information on lung cancer. We have very detailed information on treatment when they start their treatment. So we have no information on compounds, because that is not collected in the clinic. We don't know what antibiotic antibiotic is. Our reaction to that is this is not a good exercise for that. It's great for me, all the things that we will not use here in Medicare to try to estimate the total treatment able to human beings, because it's going to the compound. We know there are a lot of compounds, functional, that are not collected in the data. So it may be useful data for other things, but not for this testing. That's an exercise of self-restraint that I think we have to do more. When we see, look, there's no way I'm going to get it right here. It's not even try.
I just want to talk a little bit about always randomized trials. This is a caveat that I was one of my first randomized trials. And sometimes randomized trials or operation can actually be better. So I guess it's not good.
Right. Well, in a randomized trial, when we because they are what we call normal classes including the same as I learned about that would be normal that would be any problems that I'm just saying so that's what we do down the water on motivational studies is with the same problem. But they have the advantage that I basically using this problem we don't have actually motivational studies. So even even far better than motivational studies. And fine and but if it's on the then there is the or the formula make that engaging in the active solution is very quick and the operating that becomes very more. But the other problem is that only people will not affect how I say from the resident to the this is not the effect. But this I only say and see that is what the problem is. That kind of attitude that we have. See that is something that we have. Because you know that I'm not talking, I don't believe very about from the operation of that. Okay, why not? Because it's another thing that we need to know. So that person is not making anything the same. It's making a lot of it. And helpful. You know that. I knew that before I knew it. Now, the other thing is anything you want to engage in scientific discussion, then you want to engage. And now we have scientific discussion. I think where the study comes is that we have a very careful. Okay, good. Now I will do another thing. I have to get into another one. You have order to find that advantage for that item, and the security analysis. I don't know a number of things I have in the idea of course. There is no trivial amount of professional people who don't engage in that type of communication. They are helping us to that you know what? That's why the issue of helping us. And we have to work with those people to help them understand that it's your life. So what I would say happening is that many of these people are doctors. And they are making decisions here.
is very frustrating by the formula notation because people use different, for example, for treatment variable, they use different libraries to indicate that it's treatment variable. So I just want to hear your opinion about it just feels like you spend too much time to understand the notation, the formula. Okay, so do we standardize in algorithm field, especially sometimes you have observer data, counterfactual data. So how do we, should we standardize notation?
No, I mean, it is great that we all were using notation, but notation is the thing else. Some people feel very strongly about using A for treatment, and using A, B for treatment, and using X for treatment. I don't feel like we are going to make much progress there. You think about, for example, partial alpha. Partial alpha, some people develop that with Y for the partial alpha, and then if I make it A, some people do that faster. I do that super quick. And maybe having more complexity after that. I know that I'm going to use that.
I just feel if people use it in a consistent way, it will be much easier. Because you see one thing, okay, you immediately understand, okay, this actual data or predicted that or something like that.
Notation is a very interesting thing. I have a friend who says people feel I'm not because I know the notation, etc. And if I use Christians, nothing, instead of starting out the notation. I'm very proud of this topic tonight. But you think about people doing effective analysis of environment, they are incredible environment, they were vertical environment, and they only use they compare people who buy in the environment to people who buy in the environment. Now we're doing an observation of analysis of environment environment. So you expect they will have that problem. You are thinking your environment data happens you are having some observation areas and then you are saying there is a common difference there. Everybody comes in that you there is a history of power and you specifically have. So we have to learn how to analyze data and how proportion. We are studying unit products, mapping files, so we have the level of anything. And I like this largely of anything. I think that we have a thing that we want to do. So that is our principle in the case of identity. I don't think that's nothing about the people organization is because we have our one on we have lots of so we have lots of in our organization I think we have that kind of skill and we accept that. I mean, it's not I guess it's a lot. I think, okay, even and
regulatory agency that we request sponsors to do that. And again, how do we use that data? If we just use it as a measure from disregarding the type of statement or something else to process the file, it's not the answer to the question, but perhaps we can something like these methods is good actually, and here's about data in the
I agree with you. You have to do my business that really require learning about all run on all these classes. And many times we have non-classical data, so we know large people have the whole point of the collection of data. So we are curious about adjustable cost limitation on money here to verify all the effects, etc. We will use collection data, and that's how we be able to analyze the cost of the project. I think that's the next able to learn to do that.
But what if it becomes a great matter to put mark research? So I am in the agenda here mostly looking at first marketing data, and then we are creating a very interesting like reviewing these problems.
There are more highly controlled. There are people for us, so it's we do a lot about giving motion for law and revenue and in the book of law and use a lot of people want to and things are changing, and I think going to become of a form that was mandated by a regulatory agency, not the FDA, and to criticize the FDA and anybody around. So a company has a new form of history that rather than an index that we was selling to an detail. So this was great advancement because people didn't have to carry euros. They have to run. But they are also concerned about land surface. We have the issue. So the value was approved, and then what the agency asked for was a large randomized trial to look at a land surface. So they actually ran a large trial at the time that has a randomized trial. And I can have some people in that. The protocol of that trial said that the analysis, the primary analysis was and you think I will have crazy you don't basically analysis of a conventional instrument and engine. It wouldn't have cancer. It was a vacuum is going to be very it's going to invest a lot of money to market the new that. So after a year or two, learning that we also people going from the old instrument to the new instrument after the other a lot of 10 years, it is completely impossible to find any differences in land activity in the so in the case which is 1 month to 1 don't know how to analyze our information. What's the alternative? It's not what I'm doing the problem here. When I need to go analysis, and I have no money to do the analysis in this method, people will look and do like this, and what is exactly that. So we are at the stage now that people are becoming more and more, and even from the art problems, that the institute approach them all. But there is no example. There is no alternative. And that is what some are working on, trying to develop guidelines for the analysis of reference files.
Thank you.